Have you ever wondered what the inside of a computer looks like? You might be picturing something like this, a complex network of wires and circuits. But that's not what I'm talking about. I'm talking about something much simpler, the path that electricity takes through your device. The first general-purpose computer chip was the Intel 4004, a large, expensive device that took up an entire room and generated enough heat to literally melt the solder joints on its successor. Over time, engineers shrunk down the components of these chips, allowing them to fit more transistors onto a single piece of silicon. So if you're hoping to buy a cheap computer soon, you're likely still going to be waiting a while. But that doesn't mean you can't learn about the amazing technology that will eventually end up in your device. And as they did, they made computers smaller and cheaper and faster, too. The courses range from computer science to digital art and music, and they're adding new ones every month. Plus, they've got thousands of lessons to choose from. When we turn on our computers, electricity flows from the wall outlet through a cord, into a brick, and then into our device, but before it powers on. All that electricity has to travel through one very important component, a small chip called a microcontroller. This little chip contains a small amount of memory that stores the basic instructions for how the device should behave, like how to respond to button presses or how to display images on a screen. As they get smaller, we approach the size of a transistor at this point. The laws of physics start to get in the way. Specifically, something called quantum tunneling, where electrons can pass through barriers that they shouldn't be able to. So in order to keep building smaller and better chips, engineers have had to completely change how they work. Microcontrollers like these have been around since the 1970s, but they weren't the first. By stacking layers of different materials on top of each other, they can create a structure that behaves like a transistor without getting too small. The most common of these new materials are called 3V compounds because they were made from elements in the third and fifth columns of the periodic table. These materials allow engineers to create smaller transistors that don't suffer from quantum tunneling. They also conduct electricity in multiple directions, which allows us to create chips that are not only smaller, but also generate much less heat. But there's a problem with this way of making chips. Instead of making transistors smaller, modern engineers build them out of different materials. Unfortunately, these new materials are expensive and difficult to work with. This video was made possible by an educational platform, and thanks to them, you can learn more about the amazing technology that surrounds us all.